to True Projects. In this video, we are going to explain about a project titled English Language Accent Classification and Conversion using Machine Learning. So now coming to the introduction part. The pursuit of English language accent classification and conversion through machine learning marks a pioneering effect in the realm of linguistics and technology. By accurately identifying accents and enabling adaptive communication, this approach holds the potential to reshape how individuals from diverse linguistic backgrounds interact and understand one another. While challenges undoubtedly exist, the prospects for fostering harmony, connection, and effective cross-cultural communication through its technology are undeniably intriguing. So now coming to the objective part for this project is to revolutionize the way individuals from diverse linguistic backgrounds communicate by overcoming language barriers stemming from accents. The objectives encompass creating accurate accent classification algorithms, implementing sophisticated accent conversion techniques, and doing so in a culturally sensitive manner. The second significant objective involves the development of accent conversion capabilities. This entails designing algorithms that can intelligently adjust the characteristics of an individual's accent while preserving their personal touch and identity. The aim is to facilitate better mutual understanding without entirely eradicating the authenticity of the speaker's accent. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE that is 3.7 version is required. So now coming to the methodology part, first upload English accent dataset. This refers to the initial step of obtaining a dataset containing audio recordings of various English accents. These recordings serve as the foundational data for the subsequent analysis. Uploading the dataset involves collecting audio samples representing different accents from speakers of diverse linguistic backgrounds and uploading them into a computational environment for further processing. Second, pre-processed dataset. After uploading the dataset, the data needs to be pre-processed to make it suitable for training machine learning models. This pre-processing step involves tasks such as standardizing audio formats, segmenting recordings into manageable chunks, and potentially augmenting the data to increase its diversity and robustness. The goal is to ensure that the data is organized and ready for analysis. Third, train CNN plus LSTM model. Here CNN stands for Convolutional Neural Network and LSTM, that is long short-term memory, are two types of neural network architectures commonly used for audio and sequential data analysis. Training a CNN and LSTM model involves designing a neural network that combines the strengths of both architectures. Fourth, accent classification and conversion. The trained CNN plus LSTM model can be used for both accent classification and accent conversion. Accent classification involves inputting an audio sample and using the model to predict the accent associated with the speaker. The model used its learned features to differentiate between various accents. Accent conversion, on the other hand, involves using the model to modify the acquisite features of an audio sample to make it sound as if it was spoken in a different accent while retaining the speaker's identity. Fifth, the CNN accuracy or loss graph. During the training phase of the CNN plus LSTM model, the accuracy and loss of the model are continuously monitored and recorded. The accurate metric measures how well the model is performed in terms of making correct predictions, while the loss metric indicates how much the predicted values deviate from the actual values. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as dataset. In this we are again containing a 3 folder with the name as English, Hindi and Spanish. In English folder we are containing some audios for English, similarly for the Hindi and Spanish. The folder named as model, in this we are containing some .npy files and .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks such as making predictions on new data, performing specific operations. And the folder named as test audio, in this we are containing some audios over here for testing. Here this is the Python file which is containing the Python script in it. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on upload English accent dataset button to upload the dataset. And here select this dataset folder over here and click on select folder button to load the dataset. Here on this screen we can see 3 different accent files loaded and from dataset, and now click on pre-process dataset button to extract MFCC features for getting the output. Here we can see applications expected from MFCC features from 850 audio files. And now click on train CNN plus LSTM model algorithm button to train model for getting the output. Here in this graph you can see that CNN training completed and we got it accuracy is 93% and confusion matrix graph. Here x-axis represents predicted labels and here y-axis represents true labels. And in different color boxes in diagonal contain correct prediction count and below boxes contains incorrect prediction count, which are very few. So now closing this graph. Now click on accent classification and conversion button to upload audio test file and then predict accent and then convert all English accent file to another accent file called converted MP3. Suppose here I am selecting this audio over here and now click on open button to get the output. So now click on CNN accuracy or loss graph button to get the CNN training graph. So here in this graph, x-axis here represents iterations or hypothesis and here y-axis represents accuracy or loss values and here in red line it represents loss and here green line represents accuracy. And in this graph we can see with each increasing hypothesis accuracy got increased and reached closer to 1 and loss got decreased and reached closer to 0. So now just close this graph. So now coming to the conclusion part. In the broader context, this research underscores the transformative power of technology to bridge linguistic and cultural devices. The confluence of linguistics and machine learning has illuminated pathways for cross-cultural empathy and understanding, transcending geographical and linguistic boundaries. As this research paves the way for further studies and implementations, the vision of a more interconnected world where diverse accents are celebrated, understood, and embraced stands on the precipice of realization. By developing algorithms that can modify accents without compromising individuals' identities, this research opens doors to improve cross-cultural communication without the need to fully erase linguistic heritage.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.